Well, hey everybody. I don't do videos very often anymore. I am like a live stream guru. But this is a little bit quicker to set this up. And as I was getting in the middle of doing some fine tuning on the upper tension, I thought I would involve you with that. And this is none other than Aaron Allen's Japanese-made dressmaker model SAMB. Yeah, SAMB. Yeah, it sounds like a radio station. We're live on WSAMB. Tune in for weather later at 10 o'clock. There's a possibility of snow in Oconto, Wisconsin. As a matter of fact, it's snowing right now. It's not snowing really hard, but it is snowing nonetheless. So, what I was working on, and it was apparent that I had to dig a little bit deeper, is I was working in the final stitch offs. Let me kind of show these to you. There's the camera. Hey. So I was doing these final stitch offs and I was getting some pretty good results towards the latter parts of it. Especially that bottom row there is looking pretty, page 34. And this would have been, yeah, this is the top stitch. Here's our lock stitch. Again, getting some good results. Far right-hand side there, you can see. Especially the second row in. Some pretty good-looking stuff there. Page 34. Plus. Over here, it was way off. Well, what I found is that, and you'll find this with your lock stitch, which is what we're looking at right now, is you can make a lot of adjustments on that upper tension. Bump it up, bump it up, bump it up, bump it up. And you'll be able to get some results, but you won't be able to get solid results if that take-up spring, that check spring, is out of alignment. Let me show you what that looks like. Let's zoom way in here. Yeah. All right, that ought to be pretty good, maybe. We'll go right about there. All right, and I'll turn down our rock and roll music a little bit too. Turn my little screen around. I'm not used to this camera anymore. I'm like a laptop live stream guy. All right, volume way down so I don't have to shout so much. That would be nice. So when you tear apart an upper tension like this unit here that is for this Japanese clone machine, again, that belongs to my dear friend Aaron Allen. And Aaron Allen had previously sent me a Swedish 21E, if my memory serves me right, 21E. And she was so pleased with what I did for that machine, she ended up sending me this Japanese model SAMB. That would have been a post-World War II model. Well, let me show you this part of the unit right here, the upper tension unit. If you look really, really close, you're going to notice this is our check spring. One thing you'll notice is that it's out of alignment slightly. Where are we? See, I'm not used to this, you guys. I got to get used to it again. I don't remember how to focus this thing, to be honest with you. I think it's kind of like an autofocus thing going on, but you'll notice that this is out of alignment, and by out of alignment, I mean it's kind of this upper part of it right here that thread is going to be riding in is bent out of shape. I can't see with my magnifiers on. See how it's bent out of shape? Yeah, you can kind of see that. I'll put my hand like this so it can focus just on my hand. What that's going to cause is it's going to keep causing that thread to slide out of this little notch right here where it's supposed to be. It's going to slide out of this little notch, and it's going to be pushed over here to the inside. Might even get caught in that little track over there. So number one, we need to straighten this out as best as we're able. It's a light gauge metal, so you've got to be, it's a light gauge metal, so you've got to be careful when you're trying to manipulate it, otherwise you're going to break it. And I could heat it up a little bit, but I'm going to try just adjusting it a little bit into a proper alignment without heating the metal up. And I would use my torch to do that if I did. So let's try this and see how that ends up working out. Now, I'm going to take these off right now because I'm trying to focus and it's like impossible. I might put them back on in a little bit though. All right, so let's get down here. Kind of face that towards the camera. We're going to get a little bit closer. Again, I haven't done one of these for a while for the video camera. I think the last one was actually out at the Copper State Park thingy. So yeah, I'm not as adept at this as I am at live streaming right now. All right, let's get it kind of like that. You can see straight away how it's out of alignment right now. Let's see here. There we go. That's better. All right, so I'm going to very carefully see if I can manipulate the shape of that just a little bit. And the way I'm going to do that is I'm going to kind of hold it like this. Let me check my shot again. I'm going to very carefully grab it right here with the tweezers and see if I can rock it up just slightly. Just seeing what you can see. Actually, I'm going to go a step further and actually take it out of that mounting point. To take it out of here, so you have more control over that spring. Right now I'm kind of fighting it against the housing of here. To have a little bit more control over it, what I'm going to do is I'm actually going to remove this from the housing. You loosen this screw right here, you kind of wiggle this a little bit. To loosen it a little bit more. Kind of rock it out of there. You can separate that spring from the housing itself, so you have a little bit more control over the spring. Adjusting springs is always dangerous because, again, it's a real thin gauge metal, and there's a risk of it breaking. So I'm going to check this again just to visualize it in the machine. Yeah, as my father would have said, we're cattywampus. I'm going to try to adjust it by hand. And it is kind of cool out today, so I am going to hit it just real quick with a little bit of heat to see if I can soften that just a little bit to get that more malleable. And this torch, if you're not familiar with butane torches, they're going to put out right around 1,000 degrees. They might spike as high as 1,200 degrees, but that's quite a bit of heat, and you have to be careful so you don't burn yourself, hopefully. Yeah. Ouch. Ouch. No, I'm just kidding. There we go. There we go. That looks... You can see that in the shot. Let me get that into the shot. You can see that in the shot. That's riding more evenly now. It was kind of tilted. It was noticeably tilted out to the left before. Now we added just a little bit of heat to it. We took it out of the housing so that it's a little bit easier to control and to manage that spring so that we're not going to break it. And now we've got it straight so that that thread is going to do a lot better job of staying in this track right here, instead of, as before, it was sliding off to the right here because this was tilted and it was allowing it to slip out. So I think I'm generally pretty happy with that. So what I'm going to show you now is that, and I'll get a little bit closer again on this, although that's not a horrible shot right there. So while we have this taken apart, what I always try to do is I try to do a very thorough cleaning of the upper tension unit of any sewing machine that I'm working with. I'm going to grab more Q-tip swabs. Grab some more Q-tip swabs. And again, the importance of this housing is it's going to be the vessel that the upper tension pin release is going to be moving back and forth as you raise that presser foot lever. It's going to be riding right through this section here. It's also going to be the housing for this spring as well. And springs, again, if they're not properly maintained and lubricated, they're going to become very dirty, and they're also going to become more vulnerable as they're moving back and forth during the sewing process. They're going to become a lot more vulnerable to potentially getting bent out of shape like this one was, and or broken. And it's always a bummer when you break a check spring, because the check spring is going to be that critical spring that helps you to get that lock stitch properly defined and looking good, ought to be in Hollywood, all that kind of stuff. So what I'm going to do is I'm going to swab the inside of here before we reinsert this check spring, get that nice and clean. I say it all the time that dirt migrates. It doesn't stay in one spot. So by cleaning this properly, including the ledge where this spring is going to be resting on either side, when it's sweeping down or when it's resting at the top highest point, get all of that cleaned off of there. Get that nice and tidy. And actually get a camera shot where you can see part of what I'm working with here. So I just swabbed the inside of that. Again, swabbing it like this, getting that nice and clean. This as well. And from just a little bit of swabbing right there, we'll get closer to the camera. It's not ridiculously dirty because I had already done this once before, but nonetheless, let's see if we can help that camera again. That's all old oil and other debris, residue, stuff like that. And what I'm doing right now with my hand cupped behind here was actually a camera tip that my dear friend Christine from Canada gave me. Emma had mentioned something similar to it, but Christine really hammered the point home. She said, Scott, when you're trying to show some of those things and that camera's struggling, help the camera out. I said, yeah, why not? Why shouldn't we help the camera out? The camera's helping us. We should help it. Let's be helpful. Look at those wrinkles on my... Some palm reader is probably looking at this right now trying to tell me what my future is. Yeah. Ha-ha! My future right now is cleaning things. That's what it is. My future is cleaning things. Getting them nice and tidy. I didn't need a palm reader to tell me that. So, all right. Grab my garbage can over here. So we've got that cleaned up nicely. Now we're going to do a little bit of cleaning on this. We're also going to add some machine oil to this spring down here. Because this spring, as it's sweeping up and down with that take-up spring, this right here on this shaft is going to be pitching as well, which means it's going to be putting some level of stress on this very, very delicate metal that's wrapped in a circle like that to create the spring. So we want to reduce the stress. We want to reduce the friction as it's moving back and forth on this shaft. So we add just a little bit of sewing machine oil. But first of all, I'm going to clean that shaft just a wee bit more and get a little bit more of that dirt off of there. You don't want to put oil or grease onto a dirty surface. It's counterproductive. It doesn't make any sense. So you try to get as much of the dirt off as you can, recognizing, yes, kind of like dusting your house, yes, it's going to get dirty again, but we're going to do what we can do when we're in a position to do it, when we've got it torn apart like this. Gently wipe over the spring as well. Get that nice and clean. Also your check spring too. Again, with a check spring like this, we're going to do our best to try to clean that up a little bit as well. I'm going to make one more quick little adjustment on this. One more quick little adjustment. I'm going to pull that spring down to kind of immobilize this a little bit, and I'm just going to tweak that just a tiny little bit more. And I tweaked it too much. Don't over tweak, Scott. Don't over tweak. There we go. That's what I wanted. That's what I wanted right there. You can see that. I'm sorry. You can see that in the shot. That's a proper sweeping angle for it right there. Proper sweeping angle. It's going to keep that thread nestled in this little notch right here very nicely. If you've ever had a sewing machine where you've got a check spring like this and the thread keeps sliding over, it's either sliding to the right or it's sliding to the left. If you disassemble that upper tension, you're very likely going to find that, and you can't see it when it's mounted as a unit. It's disguised, it's hidden. But when it's not mounted as a unit and you're looking at these individual pieces, you can see if that's not going to be riding evenly up and down, and it's going to be pitched left or right, allowing that thread to slide past this notch. Because again, as this machine is sewing, this is going to be going up and down very rapidly, right? So we want to give it every opportunity to succeed. And again, treat this as a delicate metal. Gently wipe over it. Don't put a huge amount of pressure. Just enough pressure to sweep the dirt and the oil away. You set that back down there. I'm going to spoil myself and turn up my music a little bit. I think that this camera tends to manage sound better than my other camera that I use for live streaming. And this happens to be, what is this camera? I don't even remember. I haven't seen it in so long. This is a Sony, isn't it? Let me see. Where's the branding? Come on, folks. Where are you putting your branding? I can't find your branding. On the other side. Yes. It's a Sony HD high definition blah blah blah, and so does a good job of shooting the video portion. And this is the camera that I pretty much used all the time when I was doing my live stream or my videos much earlier on. So I'm going to go ahead and add a little bit of machine oil now to this spring. That's going to be allowing it to slide a little bit more easily along the lines of this shaft. Doesn't have to be saturated, just nice slick coat on there. And then what we're going to do is we're going to slide this back into this this shaft is going to go inside of this little housing that will then slide back into the machine again. And also, you can't see it in the shot right now. Let me just wait for a second. You can't see it in the shot right now. There, you can see it now. But see this opening where that upper tension is going to go? Make sure when you reinsert it that presser foot is in the down position. Otherwise, you're not going to get it inserted as full as it needs to go, as far in as it needs to go, because that little tilt lever in the back that pushes that release pin is going to be pushing the assembly out. So make sure you have your presser foot lever in the down position, and also make sure you clean this out in here as well. I cleaned it once already, maybe twice. I bet you it's dirty again already because I've done some sewing on it. The thread that we use carries dirt with it, and the dirt through the machine migrates back and forth. So what starts as clean, all of a sudden, can get, where am I? Can get dirty very quickly. Especially you can see the dirt kind of on that side, can't you? And see, I always say it. Sometimes a teacher, always a student. It was Christine. I think I said Christina before. I was thinking of our friend from Brazil. It was Christine, one of my new leaders, that recommended create that little barrier behind what you're trying to give the camera an opportunity to focus on. So see how we learn from each other all the time? And my willingness to learn, instead of just saying, well, I'm I'm the master expert, blah, 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 that's known world renowned, which is certainly true. I'm still a student. I'm still learning. I'm still learning. And you should never, ever, no matter where you are in life, no matter what position or title you have, never lose track of the fact that you still have the opportunity to learn. And by having that attitude of always learning, guess what? Everyone's going to see you as an expert because you're continuing to learn and build your base of knowledge. Goes back to what Aristotle said. Aristotle said, the truly wise person realizes their intelligence is a drop of water, their ignorance an ocean. Yeah, so I got a big ocean. I don't know about you. I've got a big ocean. Where am I? Ha, there I am. Ha ha ha! Ah! Yeah, it's Tuesday. Blah. You may be seeing this on Wednesday because again, this is not a live stream. And yes, I've been drinking Diet Coke. That's why I'm doing funny faces and stuff. So if the grandkids are saying, "Hey, he's funny," yeah, they're right. They're right. I'm okay with that. Always be like a kid. It'll keep you young, right? All right. So back to this now. And I'm going to look at that camera so I know I've got everything right. Number one, make sure you push this stem. You push this stem all the way in. You got to really, really give it a good little shove to make sure it's all the way in there. And make sure that this little screw, that you don't lose it, but make sure it's far enough out that it's not going to prevent you from sliding this all the way into position. Then the next thing you need to do is, as this is mounted, this take-up spring again is going to be sweeping. This take-up, it's kind of hard to do this. This take-up spring is going to be sweeping back and forth like this in the sewing process, right? This has to be calibrated. It has to have a certain amount of return tension, but it also has to be positioned so that it's going to be sweeping the full length of the channel that it's in right there. Right now it's not like that because this spring is too far down. See how it's too far down? So we need to turn the stem to get it to adjust that spring so it's going to get the fullness of that sweep. Watch it go up. So now I've got it at the top end of it. Now what I need to do is I need to check to make sure that the return tension is sufficient. Because again, when the sewing process is occurring, this is going to be swinging up and down and pulling that thread taut on the bottom to really make sure that that lock stitch is as it should be. If there's not enough return tension on this, it's not going to do that job. So number one, we have to get it at the correct position on top of that sweep like we just did. Remember again, we started with it way down here. It was right around down in that area. And you'll find machines that are miscalibrated like that because no one's ever taken the time, including those sewing back technicians, to tear an assembly down like this. They can't do it. They won't do it because it'll cost too much time and they have so much overhead, they're not going to take time to do this. So you can do it. So I'm going to adjust it again properly so it's at the full top area, the top section of that sweep. There we go. Just double checking. And then what you can do is you can check again to see what the sweep return is on it. In other words, how much pressure, when you push this, how much pressure is it pushing back against you? It should be about 5 ounces. And that doesn't sound like much. It's like a small little bag of candy, but it's more than you would think. And if there's too much, you can rotate this stem counterclockwise just slightly, but still don't take it back so far that it's not going to be at the top end of that sweep, okay? Because if you rotate it back too much, we're going to be back to ground zero where it's not getting that full sweep again. So we want the full sweep like that. Let's say there's not enough return tension. Then we can just turn this stem just a little bit more. And then when we get it where we want it, we'll tighten this screw again so that we don't lose what we just adjusted it to be. I'm going to give it just a tiny little bit more. return tension. It's not bad. It's not bad, but I think we could go just a little bit further. There we go. There we go. That's going to be right around 5 ounces right there. So what I'm going to do now before I lose any of that is I'm going to take my screwdriver. Once I find the shot, take my screwdriver and I'm going to tighten down this screw. Again, make sure while you're tightening it, put your thumb on the bottom, put your finger on top, so you're pressing this stem down, because it'll have a tendency to try to displace itself, and then that spring is not going to be seated in there properly. Okay? Let's tighten that screw now. And I'm starting with a little baby screwdriver. I'm going to go to a slightly bigger one, because you want to make sure that screw is nice and tight. This is one of those screws you can tighten down nice and tight. Okay. Perfect. Lovely. Now look at what we have now. We've got great return tension on that, and we also have a check spring or return spring, once I find my camera shot. We also have a check spring and a take-up spring, as I sometimes refer to them, that's properly aligned, so then when it sweeps, that thread is going to stay where it's supposed to stay. And what I've just shown you is how to take this part of the upper tension, and calibrate this check spring so that, number one, it's in the correct position, so you're getting the full sweep action of it. It's at the very top, and it's going to be sweeping down and sweeping back up properly. And then also, I've shown you how to realign something when they get bent out of shape. And sometimes folks, the users, will actually cause this to be bent. Again, it's a light gauge metal, and as they're pulling the thread either to thread the machine, or maybe they're pulling the thread out and forward as they're getting done doing a stitch line, you can very easily put too much tension in the wrong direction on this and bend it out of alignment. Right now, it's just as it should be. Now, what we need to do next is see this little channel right here. This little channel right here where that release pin is going to go. We need to put a couple of little drops of oil. I usually do it from the other end, down here. A couple of little drops of oil, then we're going to add that pin back into here, and then slowly work at getting this reassembled into the machine, etc. Okay, so I'm going to add just a little bit of oil to that. And the oil container I'm using right now that you can see in the shot is going to have a mix of machine oil and kerosene. And depending on the machine that I'm working with, I'll sometimes change the consistency of that. Japanese machines, if you don't know it, they were made post-World War II. A lot of the metal that was used to manufacture these machines was taken out of the ocean after it had soaked in there for quite some time from sunken Navy vessels. And so Japanese machines have a tendency to sometimes rust from the inside out. And I certainly found rust that was growing inside of Aaron Allen's machine, this SAMB. So in a case like that where I'm working with a Japanese clone machine that might have a greater propensity to rust, I try to increase the percentage of kerosene in here, because kerosene, if you didn't know it, is a natural rust inhibitor. And so I would go from normally around a 50-50 to a 60-40. I would go all the way up to a 70-30, or maybe even an 80-20, depending on what I'm seeing on the machine as telltale signs that that machine has some rust issues. So I bump up that kerosene higher and higher and higher if I'm seeing evidence on the machine as I'm inspecting it that there's already a rust presence in there. Because kerosene will help to halt that. Do not use 3-in-1 oil. Do not use WD-40. Please don't do that. Those are horrible things to put inside of your sewing machine or on your sewing machine anywhere. Stick with a sewing machine oil that's going to be stain-free. It's going to be a crystal white type sewing machine. I showed it to you in previous live streams. And then add your kerosene to that. There's two different types of kerosenes. There's a K1 and there's a K2 style kerosene. The only difference between the two is that the K2 is going to have a higher concentration of sulfur. For sewing machines, you don't want to have all that sulfur being introduced to your sewing machine. It'll start to attract dirt and dust and everything else. Go with a K1, which is most of the time going to be what's available in major retailers, typically in a camping section, etc. So, all right, so we've lubricated this portal now. Now we've got our pin. Our pin is again, when you raise your presser foot lever, if you didn't know this, when you raise your presser foot lever, this pin is going to be pushing against the back side of that upper tension so that there's no tension on those pressure discs. That way, when you go to draw your thread, you're able to pull that thread freely. Those discs are not compressed against that thread. When your presser foot is in the down position, those discs are pushing against the thread, and they're also going to be releasing this pin. So just keep that in mind as you're working with the machines. This is already fairly clean, but I'm just going to wipe over it real quick. See if I can find my cloth. And I'm a big fan of microfiber type cloths. They do a real good job of wicking away and pulling away dirt and such. And then what we do once we wiped it off, I've already cleaned this several times, by the way. What we do before we reinsert it, even though we added some lubricant to the bottom of this chamber and it kind of goes up that well where this pin is going to be going, we still add a little bit of oil to it. Kind of get it on the edges a little bit. You could also put a little bit on the end of a Q-tip swab, like that, and just kind of wipe over it like this. That's also a really, really good way to do it. And again, you don't have to get it saturated, you just get it nicely lubricated. And then on this particular pin, you'll notice that there is a flange on the top of it. Where am I? There's a little flared point on the top of it. And as you insert it, that's going to be at the top so that that pin doesn't basically fall out. A lot of the pins that different manufacturers would use would not have this little flare point on the top of it. And so when you were pulling that assembly out, you could easily drop this pin on the ground. This one is designed as a stop point here so that it doesn't fall through. It can certainly fall up, but there's a lot to prevent that when it's assembled properly. So we're going to slide that back into position, into that hole from the top down. The little flare point is on the top. Kind of give it a little jiggle. You can see that that pin now is the pin now is sticking out the bottom of the assembly there. And because we lubed that well and we lubed the pin as well, here's a little push. It's going to be able to move back and forth much more freely. Okay, so the next step is this piece right here. And this piece, you're going to notice, I'm just going to show you real quick. This piece right here is going to have 3 notches on the back of it. See if I can show that to you in the shot. Yeah, I've got it pointed the right way. I was looking to double check to see that I did. You see those little notches on top there? That's going to be another calibration for the upper tension. Depending on what notch on this part of the assembly, if you can look at it right here, there's a little notch right adjacent to the top point of where our spring is at. I'm going to show it to you right there. You'll see the spring, and then you'll see that little notch point right there. So depending on which of those notches on the other piece you slide this into will determine how far this spring is going to be sweeping. It'll kind of set a boundary for it. Go. And I'm going to go right in the middle. Go right in the middle. Then the next thing to go in after this, we've got this assembled right now. Next thing to go after this is going to be our upper tension discs. And no matter how many times I clean them, I always clean them more. And I would recommend cleaning them either with a rubbing alcohol, or you can use also a higher concentration of kerosene. I also will polish these sometimes as well. These have a little bit of a rough side to them, and what I do is I use a Dremel style. Let me show you. Use a Dremel style on these, and when you're using a Dremel style like a polishing brush, just realize as you're using it on different things. I'm going to come out of this shot a little bit. As you're using it on different things, this brush is going to pick up all that dirt and crap that you're cleaning with. Can't believe I just said crap, but I really did. Sorry about that. It picks up all kinds of junk. So what I do periodically is I'll stick my finger into the rag, turn it on, and clean that polishing brush. Now that started as a clean surface. Look what I just got off of that brush. And I do that multiple times when I'm polishing different parts of the machine, whether it's chromium colored coated pieces or whether it's metal pieces like these that are used as part of the assembly. It doesn't have to be a lot of time on them, just kind of gently buff them out a little bit, and then you can clean them afterwards just to make sure you're getting a nice smooth surface. Again, your thread is going to be riding between these two discs in the sewing process, so anything that can snag that thread can create issues in the sewing process. And even though the thread is going to be riding over this section of it, I clean both sides always, and also the edges, polish them up a little bit. And in real bad situations where there's rust on these, as you've seen in some of my Facebook shots, I'll also use a real high grit sandpaper, somewhere around 2,000 to 3,000 grit sandpaper on these, in order to get any of the pitting or the other issues that might snag that thread. Do the same thing with this other one. And make sure you have eye protection on if you're using a brush like this on a Dremel style tool, because those little metal barbs that act as the polishing agents will sometimes release and shoot out, and if you don't have eye protection, you could get a serious eye injury using one of these tools. So just be real mindful of that. Be real mindful of that. Safety first, right? So I just clean those up, and now there's going to be debris on them. You can kind of see that by my fingers. So now we need to clean these off again to make sure that we're not going to be putting them back in dirty after we just went through all that effort of cleaning them up. Looks like the snow is starting to stick out there a little bit, but I don't think we're going to get a whole lot. I don't think we'll get a ton. And look at these discs now. Again, imagine your thread riding between there. It's going to ride through there very nicely, and it's not going to be catching on anything and creating issues for you as you're sewing. And when you reinsert them, you're going to put them like a sandwich like this, obviously, so that this section of the disc is facing in face to face like that. Like so. So that's what we're going to do next. We're going to go ahead and drop these in. Oh, I lost my little notch. And I'm going for the middle notch. There we go. So I just drop those in like so. Those are again our tension discs. They're so essential, so critical in the sewing process. If these are not tidied up properly and maintained, I would say you want to disassemble an assembly like this, or one that's appropriate to your machine, at least twice a year, depending on what you're sewing. If you're sewing with a lot of fleece or other materials that are going to leave create a lot of debris in the sewing process, maybe even more often than twice a year, because your upper tension is really going to be the heartbeat of your machine, isn't it? I'm going to adjust this a little bit more. I can see right now with my red marker right there. I chose that middle section, but it's going to allow that spring to go up a little bit higher than I want it to go. So we're going to adjust this just a little bit. There we go. That's a little bit better. Maybe go one more click over. There we go. That's spot on right there. See, we started way over here. Let me show you again. We started way over here. I had chosen a different of those notches on the back of this assembly, and our spring, in relation to that red marker, would have been way, way too far to the right. So I just dry this out. I just pulled this out very, very carefully. Went to that notch. I wasn't satisfied with that, so I went one more notch over. And that's why they give you that adjustment on there, so you can decide where you want that sweep boundary in relation to your center point to be. I'll hold it real still for a second here. Yeah. All right. Next thing we're going to add is our base for our tension spring. And that's this little doodad right here. And I'm going to tidy this one up as well. This one I've already cleaned, but I'm going to polish it up real quick. And you notice I'm not running this at a super high speed. I'm running it actually on the lowest setting. Because even a polishing brush, which is designed not to be overly abrasive, can cause damage if you're running it on RPMs that are too high. And we just cleaned this, right? We cleaned the end of this polishing brush, starting with a clean section again to give you an idea of how important it is to maintain your polishing brush as you're going through different processes on your machine. Starting clean. Otherwise, you're just reintroducing this to the parts that you're polishing and cleaning up, which makes no sense. So you have to keep maintaining your brush as well through the process. I'm going to go ahead and take this part that we just polished a little bit. We'll just add a little bit of a very basic non-caustic type cleaning agent to it. Do you want to see what I'm using? Because we're not using a live stream. You could type in the chat, but it's going to be after the fact, isn't it? But I use a real basic cleaning agent. It's by Great Value. It's called All-Purpose Cleaner. Kills 99.9% of germs, cleans and disinfects. And this is one of the things I use on machine surfaces as well, as I did on Aaron's machine here. It's very, very non-caustic. In other words, it's not going to aggressively interact chemically with the surface of the machine or anything else you clean. It's just going to tidy things up. So I found this to be an effective cleaner. I certainly have other cleaners that I use in different polishes, but this is one of the ones that I go to quite often. The other thing is it's real cheap. I go through a lot of it, so that way, it's not going to cost me an arm and a leg. And this is the result we get, which is absolutely spectacular, I think. Yeah. So we go ahead and add that to the mix next. And the little beveled part, I should show you that. The little beveled part right there, you can see it's raised, is going to be facing up. And that's going to be our base that next our spring will go on top of. Kind of set that down carefully. And I've already cleaned this spring several times. It looks really, really good, but I'll just go ahead and clean it one more time with the microfiber cloth and just make sure that that is as it should be. Nice and clean, nice and tidy, nothing dirty and yucky that we're reintroducing to it. Now, if you've ever had a machine, I'll give you another quick little tip here. If you've ever had a machine, over time, these springs will get compressed. In other words, they're constantly being twisted and turned by the upper tension. And over time, they'll lose profile. They'll actually get shorter. And you can easily remedy that by taking, I usually recommend a wide head screwdriver. Let me grab one real quick. And then gently expanding it a little bit. The reason you want to expand it a little bit is then you don't have to turn your upper tension as high to get the same result. So as I'm grabbing this, I'm just going to go around right about center mass on the spring. I'm going to slide that screwdriver in. I'll kind of come up in the shot so you can see that. And then very, very gently, very carefully, because these springs are manufactured and they're going to have a breaking point. They're going to have a breaking point. In other words, if you try to elongate them too much, especially if you don't heat them up, they're very likely to, just snap. So I generally, matter of fact, I'll probably add just a wee bit of heat to it. But I'm going to add it by hitting the screwdriver with the flame, not the spring itself. You see smoke, you're not losing your mind. A little bit of smoke. You see that? Isn't that fun? Yeah. Yeah, heat transfers from metal to metal, doesn't it? So we don't have to hit this delicate spring with a heat. We can just hit the screwdriver and then it will migrate into that spring very nicely. We'll let it cool off a little bit so that it's safe to handle. I don't need to burn myself. That's probably not good. Now what I'm going to do is I'm going to put one finger here and I'm going to pull here and maintain that screwdriver as a center point. Just very, very gently expand this. Very gently expand this. And that's as far as I'm going to go, right there. And what I've done is I've added probably about 1 millimeter or so to the spring. So now when we reinsert it, our tension will have even more of a range if we're dealing with things where we're sewing and we're struggling with defining that lock stitch. Expanding this spring just slightly has given us a little bit of an edge. And when you reinsert it, you want to have the end of the spring make the letter E. Some people insert these the wrong direction, and yes, the upper tension will work, but it doesn't work as well. See how that's the shape of a letter E? And that's because as you're turning the upper tension, increasing it, inserting it like this will follow the natural bend and the flux of this spring design. Letter E. Yeah. We've got that inserted now correctly. Next thing we have is, this is part of the notching for the machine, is you're changing tension with this part of the upper tension right here, this knob. These are going to kind of meet together and work as a team. So I'm going to clean this next. And it looks like I probably could do just a light polishing on this, although probably not much. And when you have something like this and you're working with a Dremel, really, really hold on tight, otherwise the Dremel will grab it, shoot it off somewhere, and you'll be on your hands and knees trying to find it. Yes, that's happened to me. More times than I'd like to admit. That's probably why the sewing back guys and gals don't go into machines anywhere near to as deep as I do, because they don't want to lose parts. All right, so I'm just going to clean this a little bit with my little cleaner. Get that nice and tidy, nice and clean. Now we're going to insert this next. And for this piece, it's not that critical which way you face it, but I'm going to put the shiny side out. Shiny side is always going to be the side that hasn't been getting rubbed quite as much. Slide that into place. That's kind of what we have at this point. Just make sure my notch hasn't moved. And this is going to work in conjunction. This little piece right here that we're about to clean and insert in here is going to fit into these notches. This is going to fit into those notches. And then as that upper tension is turned, it's going to turn this screw right here, and it's going to put more compression on that spring that we inserted, and it's going to increase our upper tension. So as you turn it, it's going to push against that, compress the spring, and this is what's going to be an essential part of that right here, this little piece right here, because it's going to notch into this other piece that's just above the spring area. Yeah. All right, we'll just do a quick little cleanup on this. And this one doesn't look like it really needs to be polished. I'm just going to wipe over it with my microfiber cloth and a little bit of my all-purpose cleaner. And choose your cleaners carefully. If you don't want to use this all-purpose cleaner, it doesn't have a high scent to it, but some people are real sensitive to scents. But if you go with something else, just make sure it doesn't leave a residue behind. Leaving a residue behind can create issues, especially for the upper tension. So you can see I kind of slid that in, and then it notches together with that other piece. And that's what's going to allow us to maintain and increase or decrease our tension. Now we've got this little part right here, which is our numbered part. Really, it's kind of what we look to quite a bit, isn't it? It's what we look to as far as adjusting that tension. And there's at the 0 point right here, you can see the 0 point. There's going to be a little piece that sticks out. It's really hard to see, but it's right there at the top. It's really important when you put this back together that that little piece is to the right of wherever our spring piece is that we just put in, because that's going to be our 0 point so that we can turn the tension. I'll sometimes have it a little bit to the right, and then I'll go to try to turn that tension, and it won't turn because there's a stop point. I'm going to clean this, and then we'll put it together, and I'll try to show you what I mean by that. And this does have a couple little Mars on it, so cleaning it's not going to take those off, but at least we can get rid of the dirt. So and certainly if you're in areas like this and you know that this is going to be turning like that, getting a little bit more detailed and get in there with a Q-tip with some of that general purpose cleaners are going to allow you to get even more of that dirt out. Get that all tidied up, and you just kind of keep it. Right now it's very prone to falling apart because there's nothing holding it together, so just be aware of that as you're setting this up. And again, when I put this in, I'm going to put the 0 just a little bit to the right of that last piece that we put in that has that little flange that interfaces with that that dial type thing. It's going to be kind of our center point. As a matter of fact, I've got to maybe adjust it just slightly, because that center point, we want it to be right on that red marker that we have, so we have a true 0 point. And when I put it back in, I'm just going to set it up a little bit with that 0 to the right of that. That way this will turn. Otherwise, it's going to hit that stop point and it's not going to turn. There we go. I've got my final piece, and I'm going to go ahead and screw this on, and then I'll show you another calibration point. Let me just wipe this a little bit with my rag. I'll show you another calibration point that's really, really important. And I forgot to do one thing. I'm going to put just a tiny little drop of oil on the threads right here so that that's a little bit easier to turn. Really, really light. Make sure that doesn't move. And then as you're screwing this down, you're going to want to kind of hold this. See this white section right here, the one that we have just below? This little white section right here, kind of whitish yellow that we have right here. You want to compress that just a little bit. In other words, I'm kind of pushing this against the spring a little bit so I can screw this down. 9. And get all the way up to 9. You look at it in relation to that red marker right there on top. There it is. So I still have to go a little bit further. So then I turn this all the way back the other way, as if I'm reducing the upper tension. I'm going to go ahead and push this section in right here, the yellow part. I'm going to push that in. So if I don't push it in, I can't move this because there's a little pin on here that inserts into this. So I've got to compress this just slightly. All right. I'm going to turn this a little bit more counterclockwise, just a little bit. Release that section, and it should pop back in. There we go. Let's see how far we can go now. All the way to 10. We're about as close to 10 as we can get in relation to that little red marker on top. Hopefully you can see that red marker in the shot. I think you can. Yeah, there it is. So we started at a point where initially when we reassembled this, we were only able to turn this knob as high as 8. And then by releasing this intersection here, compressing it, and then adjusting this, we're now able to get the full range of the upper tension. Does that make sense? I hope it does. Now we can back that off, go all the way back down to close to 0. It looks like I have to make a slight adjustment on that. Let me see if I can do that. Yeah, that's going to be about as close as we can get. I think that's going to be really good. I might mess around with that a little bit more. Yeah. So at any rate, that's the assembly and cleaning and calibration of this upper tension unit designed for this SAMB model that was made in Japan. I hope this is helpful to you. We did a number of things to set this up for success, and now we're going to reinsert it into the machine. Yeah. And again, make sure your presser foot lever is at the down position so that there's no pressure against this little release pin right here. Yeah, see, if you zoom in way like that, then it's harder. Yeah, we don't want anything pushing against this pin right here. Okay, so I'm going to go ahead and insert this back in. We'll make sure we get our red mark at the top. My presser foot lever is down. Get it inserted all the way in properly. Then once I get into the position, I'm going to hold it in place. Do not raise your presser foot lever right now. Don't raise your presser foot lever. And then what I'm going to do is I'm going to come on the inside of here where the set screw is. And on different machines, sometimes the set screw is on the inside of the arm. Sometimes it's inside of the faceplate area. It's going to depend on the machine. Well, this has been a very good opportunity. I decided to do this spontaneously. Apart from having my oily fingers allow me to drop the upper tension, which you don't want to do that. There we go. You don't want to drop the upper tension like I did, but thankfully I've got cushy carpeting that it was sitting on top of. Adjust that just a little bit. There we go. And again, as you're tightening that set screw, just make sure you're gently pushing against this tension so that it's inserted all the way in. All the way in. Get that nice and snug. Now we can raise our pressure foot lever. And we can't see it because unlike some of them that have an open field where you can see those discs are actually loose, this is designed as more of a closed unit. So the way we can tell is when we draw thread through it, those are all the way down. And I'm going to back off this upper tension now. We're all the way up on 10. I'm going to kind of go down probably to about the 5 range, right around there. And then once I do another stitch off, I'll be able to tell if that's the correct spot, or whether or not I need to go up with it if that lock stitch is not defined, or go down if it's overly defined. The other thing I'll show you real quick in this quick little video is this is the foot controller. Let me come out on this shot. This is the foot controller that Aaron sent with the machine. It's a Mercury style foot controller. They're generally going to be rated anywhere from 1 amp up to usually about 1.2 amps. Now the problem with this foot controller is two things. One is it's got a ceramic insert which is real sensitive to heat, and then it's got a carbon infill which will retain the electricity if you're doing a lot of slow sewing. In other words, if you're sewing in this range right here, where you're in the upper portion of this foot controller, you're not way down here, but you're up here and you're trying to really sew with a lot of control, it's going to cause the electricity to build up in here because it's a carbon base. It kind of holds that electricity, and then this will start to get super hot. The other problem with this foot controller is that the motor that this SAMB has with it is a 1.5 amp motor. You heard me right, 1.5. Now it was made in Japan, so they may be a little bit off. In other words, maybe it's closer to 1.2, 1.3 instead of 1.5. 1.5 is probably more of a marketing stunt than it was an actual amperage output. But nonetheless, this one here is only rated at about 1.1 amps. And we've got a motor that's somewhere between 1.2 to 1.5. If we believe the faceplate on the motor, then it's 1.5. That's going to cause this to overheat even more because it doesn't have a high enough amperage tolerance. Again, you always want to make sure that the foot controller has a higher amperage tolerance than the motor on the machine. So if the motor on the machine is, say, 1.1, this should be 1.2. If the motor is 1.2, this should be 1.3. If the motor is 1.4, this should be 1.5 ideally. Or at least match the motor, you know what I mean? So if the motor is 1.5, ideally we want to have a foot controller that at a minimum is going to be rated at 1.5. This one was not going to work because of the ceramic insert, because of the carbon that's infilled into it as well, that retains all that electricity and creates a lot of heat, and because it's underrated. So this one was a no-go. So I ended up going with a foot controller somewhere. I'll find it. Oh, there it is. I ended up actually going with an electronic foot controller. And I went with an electronic foot controller, and I had to rewire it obviously because the setup on this Japanese machine is it's got a block style plug-in where you plug the motor and the light into the appropriate receptacle. And one of these is going to be intermittent, where there's not a constant electricity flow for the motor until you depress the foot controller. And then the other one is going to be a constant electricity flow that's going to supply the light. So I had to rewire this for Aaron's machine. And with the electronic one, it's got a small little circuit board inside of it. A small little circuit board that eliminates the issue, for the most part, of heat buildup when you're slow sewing. So you can have this foot controller pressed down just a tiny little bit, because there's no carbon insert, because there's no ceramic base to it. It's going to stay nice and cool generally. And that is the benefit of the electronic foot controllers, even for our vintage sewing machines. If you're going to be doing a lot of free motion quilting, if you're going to be doing freehand embroidery, this type of foot controller may be the one you want to consider, because if you're really regulating that speed at a low level, you're not going to have the overheat issues that you would with a foot controller like this one. Also, the other benefit of this electronic one is it has a rating. Again, like the motor, do we assume that it's absolutely spot on? Not necessarily, but they've given this a rating of, let me get real close to the camera. They've given this a rating of 1.5 amps. So we've taken this electronic foot controller, we've mirrored and matched it against the motor that's on Aaron's machine. We've eliminated the carbon stack that's going to retain that electricity and create a lot of heat. And we've also taken out the equation of the ceramic insert that can also hold a lot of heat as well. So we have the proper amperage in relation to the motor, and we've eliminated the other factors that might create issues for Erin if she's sewing more in this lower range on the foot controller instead of pedal to the metal to the pedal. Yeah. So sometimes electronic foot controllers can be the right solution, and in this case it was the right solution for Aaron's Japanese dressmaker model SAMB. Oh, what fun, huh? And I'll just do real quick, I'm sure I'll be demonstrating this machine further, but I'll just real quick spin it up so you can kind of hear the power of what they're rating as a 1.5 amp motor. Give you a chance to hear this puppy fire up. And, whoops, wrong way. We'll go over by the balance wheel and you kind of see it spin up. And then eventually you'll see this live stream, probably, and you'll see the fruits of our labor in all that we did for this upper tension unit to set it up for success. Yeah. All right. Blah, 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 blah. Let's go over by this balance wheel. Right about there, I think is pretty good. I'll kind of lock it in place. I'm going to mute my music for a second. Shut my heater off for a moment. I'm going to plug these in. And again, you know, be careful that you plug them in correctly. One of these on the block. I'm trying to look at the camera. Oh, you can't see a thing. One of these on the block. One of these on the block is going to be labeled motor. That's going to be your intermittent circuit, where the circuit in here will not be completed until you compress the foot controller, and then it completes the circuit and then it actuates the motor. The other side is going to be hot all the time for the light, so you just have to make sure you plug them into the correct one. Otherwise, things won't work as intended. So I've just plugged those two in, and all I want to do is just give you a little glimpse of the power. Oh, that's a heavy machine. Yes, it is. Give you the power of this as if we were going to be winding a bobbins. Check out that balance wheel there. And again, I'm going to go in the lower range to begin with. Let me come in a little bit closer now. Whoops, wrong way. Go in a little bit of the lower range with the foot controller. I'll kind of hold this up here so you can kind of see. Wrong way. We'll go right about there. I'm going to be in the lower range to begin with. And now I'm going to spin her up nice and fast. Lower range. So where I've got it in lower range right now with this electronic foot controller, and I can do this for quite a long time and not have any issues with overheating. A regular foot controller that's carbon based with that ceramic insert is going to heat up very, very quickly. We'll add the load as if we're going to wind a bobbin. Kind of drop down. Now we're going to give it a little bit more power. Even with a load of the bobbin winder on there, creating a lot of friction against the inside rim of that balance wheel, we're still getting incredible power now after I've gone through and did a complete service of that motor on this machine as well. So if it wasn't getting 1.5 amps before, which not even close, it's getting the fullness of whatever that amperage is for this motor. Again, you can't always trust the markings on the motor as far as what the output of that motor will be. You'll look at something and it says 1.1 amps or 1.2 and you're thinking, oh, this thing's going to be a monster. I've gotten a lot of those machines in because the customers have basically said it's putting out like nothing as far as power. And there are a lot of things in the motor, kind of like I just showed you in the upper tension, that have to be calibrated to set that motor up for success, just like an upper tension unit. But there's other factors that play into that as well, as that power is being transferred from the motor through the pulley to the belt to the balance wheel, down the main shaft, and then eventually down the needle bar to the material that you're sewing. So just take that into account. You can't always accept that the machine is marked appropriately. And sometimes you'll find that on the back of a machine, there's going to be a nomenclature plate on the back of a machine, and it's going to give you a certain amperage rating for that motor. And then you'll decide to get ambitious and you'll take the side of that plate off and you'll dig in there and you'll look at that motor and you'll find that the motor is marked with a different amperage than what the nomenclature plate on the back of the machine says. On the back of the machine, it might say 0.6 amps or 0.7 amps. You get into the motor and you find that, in fact, the motor is rated at 0.9 amps. So it can go either way. Or you'll find on the back of the nomenclature plate, it says that this machine is rated at 1.0 amps, 1 amp. And then you get into that motor and you find that that motor is going to have a separate plate that says 0.7 amps. Now you might say to yourself, well, what's the big deal? It's 0.7 versus 1.0. You're talking about almost the difference of throwing a featherweight into the equation. A featherweight is rated at a 0.4 amp motor. If you've got a nomenclature plate that's saying 1.0 amps and you've got, say, a motor that's saying 0.6 amps, and I found that numerous times with different manufacturers where the motor is rated differently than what their plate on the back of the machine says, then you're talking about losing the power of a featherweight. And you know what? I've shown featherweights sewing through 2 layers of leather, so it's significant. So just be aware of that. You're going to find those discrepancies, and then you have to account for it as far as what that machine is capable of doing, especially if it hasn't gone through the workshop magic. And the workshop magic, again, takes a machine from sewing, say, at this level, to sewing at this level. That's the workshop magic, isn't it? Yeah. And that's why I'm so fortunate, I'm so blessed to have folks from around the world that send their machines here. I've talked about it in a couple of the recent live streams, and then I've gotten sidetracked with projects that took longer than expected, which happens regularly. And But I am going to get Adam's machine onto the workbench really quite soon, I'm hoping. And Adam's machine was sent all the way from London, England. It is a Swedish beauty, and I'm going to have to use a step-up converter to take my 110, 125 volts and push them all the way up to between 230 to 250 volts. So, you know, it's sometimes okay to buy a European machine. Maybe you'll find just a jewel of a machine, kind of like the one I got from my friend over in Germany. That came, interestingly, it came with an American motor, so I didn't have to deal with that. But some of the machines you get from over in Europe are going to be European motors, so they're designed to run on 230, somewhere between 220 to 250, kind of that range. And there you'll have to look at getting a step-up converter that will take our US voltage of around 110 to 125 and step it all the way up to 230 to 250. Same thing is true if you're over in Europe and you have an American machine. Let's say that we have someone over in England that says, I really want to have one of Scott's machines, and I'm going to run it on a converter. Then they'll have to have a step-down converter that will take their voltage from 250 all the way down to about 125. And those are available. They're available out there. I've shown them a couple of the live streams. So realize that that is an option. Instead of looking at changing a motor out or rewiring a motor, you can simply use a step-up or step-down converter as well and have the freedom to enjoy a beautiful European model. Maybe it comes from my friend Alex Askarov over in the UK. And he's got a beautiful machine and it's wired for UK voltage. Don't let that be a showstopper to potentially acquire one of Alex's machines, because you can just get a converter that will step down that voltage. Excuse me, reverse that. That will step up that voltage if you're in the US, and it'll allow you to operate one of Alex's machines that's wired for 230 to 250 to step that up to the proper voltage from our 110 to 125. Okay? So, yeah, I mean, there's options out there, isn't there, to enjoy the fullness of vintage sewing machines worldwide, regardless of what our grid, our electrical grid is set up for, so that we can have a lot of fun with machines that might come from other places in the globe. Certainly, because I think I have the best process in the world. I've never met anyone that has challenged that to say, Scott, you go deeper into the machines than anyone out there. You dig into the machines at a surgical level. And I don't just do that to be a showboat. I do that because it transforms that machine to a level of greatness that it otherwise could never, ever achieve, which means the performance level goes crazy off the charts, kind of like this one you just heard. And it gives you a level of delivery down at the needle that you can't get from any other machine in the world. But, you know, all of that said, if Alex, my good friend over in England, and his lovely wife, Yana, if they present a machine, I can tell you, you can buy that machine confidently and know it's going to be top shelf. And if it's electrified, you can get one of those, get one of those step-up converters so that you can power that European machine over here in the US, or vice versa. I mean, you can get a step down as well if you're over there in Europe and you want to buy one of my machines and you want to use an American motor. No problem. You just step that voltage down and it's a win-win all the way around. So there you go. A quick little impromptu. I didn't plan on doing this, but I'm glad I did. I'm not glad that I dropped the upper tension, but I'm very thankful I've got a thick carpet that it landed on very gently and no harm was done. But that's the problem with getting oil on your fingers sometimes, isn't it? Your fingers get slippery and before you know it, gravity works, doesn't it? So take care, everybody. God bless. Hope you've enjoyed this little impromptu about Aaron Allen's very cool Japanese dressmaker SAMB model, and what to do with that upper tension to set a machine up for success. The things I taught you today are not going to just apply to this Japanese dressmaker. They can be applied to any upper tension unit on any machine, including light industrials and even commercial machines as well. So, wow, we learn together, don't we? I feel inspired to ring the bell. Yes, I do. And remember as well that we reached a milestone recently in hitting 13,000 subscribers. And I've got a contest going right now where I'm giving away a fully restored featherweight for this contest. And I'm even going to offer the option of it being custom painted as well in my paint shop. So you don't have to go with the traditional black-blue color. You can opt for, I'll give you a small list of color choices, and you can opt to go with a custom color instead of a traditional Singer color. So right now the response has been real slow, but I know that a lot of you are really, really meticulous about writing just in the right way. Paula Noel and I talked about this, and you might be sitting in the wings right now carefully drafting your creative piece, and you're going to be submitting it. You've got until December 6th, I want to say. It's posted on Facebook, and I also have a YouTube video live stream done on it as well, talking about the dates of the contest. It's already ongoing right now, and I think it ends December, don't quote me, either December 4th or December 6th. Check that, because I've got that in the video on YouTube. I also have that on the Facebook post as well. I probably should check real quick so I can give it to you correctly. Hold on a second. That way I don't have to say, don't quote me on that. I can say, you can quote me on that. All right, where is it? Somewhere down here. Somewhere, over the rainbow. Maybe I need to go to Facebook and find it. I was looking for the still shot that I used to promote the contest. It's somewhere on here, somewhere. There it is. Kind of blended in a little bit. Okay, the contest, you can quote me on this now. The contest runs from November 8th, so it's already started, November 8th, until December 6th. December 6th. So you have to have your submission sent to me by email, and I've got all that posted on there as well. It's my first and last name with ms@gmail.com. You can see that on there very easily. But it's got to get here before midnight on December the 6th. If it doesn't arrive here by midnight on December the 6th, then it's late and I'll have to disqualify you. And I think this is a real fun contest. I'll just give a quick little plug on this. I think it's a fun contest because you've got a whole army of celebrities. I think there's a total of 17 celebrities that you can choose up to 3 of them, minimum 2, maximum 3, and you can bring them onto your team. And you can either do a cool project that's going to be auctioned off. You can do a product development. You can actually create a product, a virtual product with your celebrity team, and then you can market it to the people on Shark Tank, and they can loan you the money because your company is a startup. You don't have a lot of money. So the Shark Tank rich people then will give you money to develop this real cool product that you're developing and promoting with your celebrity team. Or you can develop a nonprofit, a 503c3, and you can do good in the community working with your celebrity team, and you just write a fun little creative piece about that. And all that stuff is on Facebook. I talk about it as well in the YouTube video as well, where I introduced this new contest because of us hitting this milestone. And I'm thinking that someone wants to win a custom painted featherweight, fully restored from my workshop, that comes with a lifetime warranty. A lifetime warranty. A lifetime warranty. How do you beat that? How do you beat that? And all you have to cover is the shipping. I talk about that in all the rules and the blah, 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 and all that stuff as well. So you get a featherweight, custom painted, fully restored, lifetime warranty that's going to be valued at about $1,200 to $1,500. It's not a standard featherweight like you're going to find on Etsy or on eBay, that those folks have polished it off a little bit and then they throw it on, onto the auction block or the sales block on eBay, and you don't know what you're getting. You saw today, just as we went through the fine-tuning and calibration of this machine, there's a lot of things left to chance when you buy a machine secondhand on a venue where the people selling it, other than knowing approximately what the machine might be worth, they don't have a clue and haven't done a thing to that machine. Whereas that featherweight I'm giving away will have been, between the paint shop and here, probably about 30 to 40 hours of work between fine-tuning the machine, going through my incredibly detailed surgical process, and then the paint time work as well on the machine, especially if we go with a custom color. So, and then laying down the decals meticulously, clear coating the machine, and creating a fortress of protection of that machine, kind of like Paula Noel's that I did for her on her 201-2 that had 7 layers of clear coat on it. I mean, that is preserving and protecting a vintage sewing machine against literally anything that could damage it with that many layers of clear coat. And I usually do featherweights somewhere between 7 to 10 layers of clear coat. So this is going to be, it's going to be almost bulletproof. If one of the grandkids scratches it, you'll be able to polish out the scratches very easily. It's got so much clear coat protecting that new paint and those new decals. So I'm hoping we get a lot of entries into this. We've got a panel of judges right now that are very excited to read the entries. We've only gotten 1 submission so far. Only 1 submission. And a contest like this doesn't go. It doesn't happen unless we get a minimum of 3 to 4, hopefully more. 3 to 4, hopefully more. 3 to 4, hopefully more. I didn't mean to rhyme that, but it's kind of catchy. So we've got to get at least a minimum, bare minimum, 2 more entries. And hopefully we get a lot more entries, kind of like we did for the Calico contest, where we get 4, 5, 6, 7 entries, because the judges are just ramped up right now, ready to read these entries and begin to evaluate them, and then reread them again, and then reevaluate them, then eventually cast their vote for that grand prize winner, that second runner-up, and that third runner-up. We're not going to just have 1 winner in this contest. We're going to have a grand prize winner, second runner-up, third runner-up. So we're really going to have 3 winners for this contest, which I think is super cool. That way it's not just, oh, 1 person wins, done, everybody else doesn't get anything. We're going to have 3 people that get, the grand prize winner is going to get a featherweight. Wow. Wow. The others are going to get some really, really cool things as well. And the people that were in the last Calico contest that were runner-ups, not the grand prize winner, can attest to the fact that I sent out some really cool stuff, including my pink grease that I have people contacting me all the time saying, how can I buy this stuff? And I tell them, I'm not selling it. But if you send your machine and there's gears or other appropriate high friction points that would benefit from my pink grease, I'm going to use my pink grease on it. Well, with the last contest, I sent my pink grease to the judges as a special thank you for the time that they vested in evaluating all of those great writing pieces for the Calico contest. I also sent it to the grand prize winner, or I actually should say I gave it to the grand prize winner because she was in the workshop. And if you didn't see that live stream video, the winner, Kathy Pecor, came to the workshop, drove 200 miles, 400 miles round trip to come and collect the machine that she won, a 170th anniversary Class 15 Singer that was done just for the 170th anniversary celebration for the Singer Sewing Machine Company. It was made in India, which was kind of interesting, and it was a replica. And anyway, check those out. It's a really cool video showing her in the workshop, and then I did a follow-up as well because I kind of pushed that replica as hard as I would a standard vintage sewing machine, and I kind of broke it, but then I fixed it. And then she left a happy camper, and she said she sent a picture to me that I shared on Facebook of one of the recent projects that she did on that 170th anniversary hand crank sewing machine that she won, being the grand prize winner. So yeah, get your entry in before December 6th, and anytime before that. And I'm wishing you the best with that. How many other channels out there? I don't know of any other channels that are sewing related like mine, restoration related, restorative related, blah, 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 that give away the things that I gave away. I showed you on one of the recent live streams that beautiful 12K from the 1800s that was sent to me by, oh goodness, blanking on her name again. Hold on a second. It's almost coming up to the workbench. She goes by Patricia, but she also goes by Trish. Rabin. Trish Rabin. That sent a beautiful 12K from the 1800s that she originally purchased from my friend Alex Askarov over in England. It was shipped from England all the way to the U.S. She had a mishap where the bottom let go and she dropped it. I think I've told you about this a couple times. It crashed to the ground. I believe it landed on concrete and it bent and damaged this beautiful 12K that Alex had sold her. She reached out to him and said, I'll pay anything to ship it back to you so you can fix it. And he basically told her, you know, all of us have specialties. And Alex basically told her, I'm not the right man for the job. Send it to Scott. And I was so honored by that because, like many of you, we have such a deep respect and appreciation for Alex Askarov. He's been in this field probably longer than most any of us. He grew up in a sewing machine type factory where they were manufacturing goods for babies over there in the UK. So he's been, since he was crawling, practically, he's been around sewing machines. And then his family kind of reared him up into that space. And eventually he worked for that factory and did different things for them as well. So, I mean, to get a recommendation like that from Alex, I was very, very honored by that. But you know what? I think I've earned it. And I'll just say that with a two-edged sword. You know, I've been in the space about 23 years. And I've done machines for people around the world. I've done machines for celebrities. I think I've earned that respect from Alex. And I think that's what he was saying is I respect Scott and what he's done in the space. And he's the better man for this particular repair job. So Trish's will eventually be on the workbench, and I'll be replacing those damaged parts using my endoscope to go into that machine and make sure that I check for any collateral damage that occurred from that fall as that machine struck the ground with so much force. And then eventually get that machine back to Trish out in Virginia. She's been very patient, pleasantly persistent in touching base occasionally and saying, how's it going? How are things going? Which my great customers always do that. They do a touch base. It's always done with, no, I shouldn't say always. It's generally always done with grace and with respect and with kindness because they realize how busy I am. But occasionally I do get that persnickety, nasty customer that can be a little bit pushy and want to go to the front of the line and bump all of you that are waiting for your machines out of the way, saying, let me go to the front of the line. Kind of like that nasty character from Willy Wonka and the Chocolate Factory, Veruca Salt. You remember her, Veruca Salt? She was always pushy and I'm important, you're not. I'm important, you're not. Those are really far and few between those customers that I get, but occasionally I do. And I remind them with a lot of... Hold on a second. Actually, an incoming call from Minnesota, but I've got to send it into voicemail because we have to wrap this up. I remind them that all of you are as important as they are. And because you've methodically worked your way up that long line of machines heading towards the workbench, that you've earned the right of having the place that you have. And they usually don't like to hear that, but that's the position that I take. You've waited, they need to wait. And Trish has been very patient in waiting for her 12K to be to receive the proper treatment and surgery and repair that it needs after that fall to the concrete. Anyway, back to the contest. December 6th is the cutoff. If you want to win a fully restored, custom painted featherweight that you'll be able to take to your quilting retreats and your expos and invite friends over and they can all drool on it because you won it for free other than covering the shipping, then jump into this contest. It's going to be a lot of fun, I think, to put together a celebrity team, no matter which of those options you take, whether you end up, developing, I'm just blanking right now, whether you end up developing a product and you go to the Shark Tank with it, that's one of the scenarios that I give you, or whether you end up developing a 503c3, a nonprofit, or whether you end up developing whatever the first option is. See what happens when your mind just goes blank? And any of you that have never been in front of the camera have no idea what I'm talking about. Project. Option 1 is a project. I said it the first time without missing a beat, and now I'm just getting kind of worn down a little bit after this video, and I'm thinking, what was option 1? It's a project. So a project, a product, or a purpose is kind of the way I broke out the 3 options you can do for this contest. I think it's a lot of fun. I think it's a cool idea. I must say so myself. And I'm hoping that we get a lot of people that jump into this, and that the judges have to struggle mightily to try to narrow it down to a group of the 3 that are the best of the best in our judgment. And of course, there's a subjectivity to this. Other judges might pick other pieces, but I trust my judges implicitly. Great judging panel, and they're very fair, and they don't just make it a quick little read through fast and blah, 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 blah. They read these pieces again and again and again and again and again to digest them, to make sure they're making a real fair choice of who's going to get that grand prize, who's going to be the second runner-up, who's going to be the third runner-up. And don't think of it as if you end up getting picked for second runner-up or third runner-up, never ever say, I lost. That would be like joining the Olympics and getting a silver medal or a bronze medal and saying, I lost. Well, you didn't get a gold medal, which would be the grand prize, but you still got a medal. So if you end up entering this contest, and for whatever reason, we don't pick your creative writing piece, the last contest was a really tough thing to narrow it down to those final 3. And even then it was a struggle where one judge voted for this one, another judge voted for this one, another judge voted for that one. It was really tough. But if you end up not getting the grand prize after entering this contest, and you are a second runner-up or third runner-up, man, oh man, I'm going to be doing a dance for you. I know the judges will be doing a dance for you as well, because that's like winning a medal at the Olympics. You know, especially if we have a larger group of selections like we did for Calico. It was really tough. And so if you get one of those positions, grand prize, second runner-up, third runner-up, man, oh man, I would be proud if I were you, because that is saying something about your writing skill, your creativity, how you've implemented your celebrity team into your story, all that kind of blah, blah, blah stuff. It's a gift and a talent to be able to write a piece like that. And I'm hoping that everyone takes that challenge. You only have until December 6th. And with the holidays of Thanksgiving and approaching towards the holidays of Christmas and everything else, needless to say, all of us are busy this time of the year. That's why, after talking with my fellow judges, we gave even a longer period of time to write the story. So jump on it, take advantage of it. And again, thank you to Aaron Allen as well for sending this really cool machine, this SAMB, had to think about that, this SAMB that I had a chance to show you just a tiny little bit of what I do in calibrating and fine-tuning machines. That's like the tip of the iceberg that I showed you today, but it's an important tip of the iceberg nonetheless. So God bless. I'm going to put on a little bit of music. And some of you that are watching this, all of you that are watching this as a video, because it's a video, it's not a live stream, can chat a little bit more, and then things will come to an end after the music ends. That's it! Ha-ha! All right. I'll set my phone down, and eventually I'll call back this person from Minnesota. Minnesota, yeah. All right. Take care, everybody. Oh, that's really boring. I feel like we're going to be doing like little snowflakes or something. Let's not do that. All right, that's pretty too, but I want to pep it up a little bit. Give me something peppy. Yeah, this will work. This will work. Yeah. That was awkward. Our music just ended. I'm going to act like it didn't. And just keep on going. There we go. Come out on this shot. Right about there. Stop right there. Perfect. Lock it in. Right, the music's not too loud. Actually, there's no music, but let's pretend like there is. Yes. All right, take care, everybody. God bless. Well, that's true. You're right, Dr. Singer. You're right. Thank you for that. Japanese machine. We bring out Umi and her friend from Japan. Forgot about that. Thanks, Dr. Singer. Umi is so tall. Look at that. We cut her head off. That was freaky.